Second problem. So, they may ask any problem, any instructions, explain with the help of examples. Means you can take any random value you wish. Okay, you can take r naught is equal to some value, r1 is equal to some value, and r2 is equal to some value, and you can explain any instruction. Suppose in the exam, theory exam also, if they don't give this, okay, explain the following instruction subs r1 comma r2 comma like this if they give, so you have to explain actually. So you can explain by taking some easy value like r naught is equal to 0, r1 is equal to 2, r2 is equal to 1. Like that you can take any value and you have to explain. So let us take this example. If r naught is equal to 0, if r1 is equal to 2 and r2 is equal to 1, find the content of all the three registers R0, R1 and R2 after the following instructions are executed in isolation. In isolation means think that only that instruction is executed. They are not in series. Okay, one instructions are executed separately. Isolation means. And mention if the current program status register is updated or not. So first instruction is add R0, R1, R2. Logically shift left side by 1. So add instruction is it is going to add. This is the destination. R0 is the destination. So it is nothing but add R0 comma add R0 comma R1 comma R2. If they give only this, okay, then it is destination is R0. It is equal to okay R1 plus R2. This is the source operands. Okay. If I give add R0 comma R1 comma R2, R0 is the destination, R1 and R2 are the source operands. But here extra they are given as logically shift left side by how many times? 1. So this is once again the usage of barrel shifter. So I will show you the barrel shifter. So again, this is the barrel shifter. This is the source operand one register. This is second source operand. Okay, if you don't shift any second register, then without any shift occur in the barrel shifter, directly it will come here. So if I give add R0 comma R1 comma R2 means R1 and R2 are going to add, and without any shifting in R2 it will add those two and answer will be stored in R0. So that is the case. Suppose if they ask move add R0 comma R1 comma LSL by 1. So here logically shift left side means while coming to the accumulator it will pre-process and will shift the this register content by how many times that we have to specify in the problem itself. So now I'll go to the problem. So this is the case without any barrel shift usage. It will just add R1 and R2 and answer will be stored in R0. R0 is the destination, R1 and R2 are the source operands. So logically shift by 1 times means in the barrel shifter it will pre-process. So which register is going to shift means R2 comma LSL. So R2 is going to shift. R1 will directly come. R1 will directly come. This is R1. But R2 is going to pre-process and it is logically shift left side by how many times? 1 time. So let me take R2, logically shift by 1 time. Then I will add it to R1. Then answer will be stored to R0. So R2 is given. See the problem. If they don't give this one, okay, you can take easy numbers in the example. Okay, you can take random some values and you have to explain with example. Normally they'll ask explain the following instruction with example. That means you can take your own values. Don't take complex number, take simple number like r0 is equal to 0, then 1 and 2 like this. So they are given in this problem, they're given r0 as 0, r1 is 2, r2 as 1. It is a 32-bit number. So x is hexadecimal. Each you have to consider as hexadecimal. If you split into binary, each hexadecimal you have to split into 4 bits binary. So R2 is given as 1 now. So you write in terms of binary. So each zeros are represented by 4 zeros, and last one is there, no? This one. This one is written as 4 bits 0001. Why I am writing in binary means you have to shift logically shift by how many bits. You have to shift logically shift left side by 1 time. So left side, if you shift, this MSB will go. This MSB will go, and zeros are appended here. Here, 0 appended here. So after left shift, again this 4 zeros, 0, 0, 0, no changes will happen. Okay, that's why in the example, you take simple number so that easily you can find out the answer. So this 1 becomes left side, means it becomes, this 1 is shifted left side by 1. This 0 will come here, this 0 will come here, this 0 will come to here. So now it is 1 becomes 2. So I already told, logically left shift means multiplied by 2. So if I shift once again, left shift, this 1 0 becomes 1 0 0. That is nothing but 4. So logically shift left side by 2 times means it is multiplied by 4. If I shift 3 times, it becomes 1 0 0. That is 8. So left shift by 3 times means multiplied by 8. Okay. So now you have to write, you have to specify, find the content of R0, R1, R2 after the instructions executed. So R0 is 4. Okay. Because R0 is actually destination, no? This is the destination. Please see here, R0 is destination. So R0 should be modified with this result. So this result is 1 minute. So because since we have not added here, so it is 2. It is 2. After logically shift R2, after logically shift, it becomes what? 2. For that one, what we have to add? It is now actually R0 is equal to R0 R1 plus R2 left shift by 1. R2 left shift by 1 time. So R1 is, what is the content? See the content of R1. R1 is actually 2. R1 is 2 plus then R2 left shift by 1. So R2 is actually 1. R2 is left. If you left shift by 1, it becomes 2. So it becomes 2. R2 left shift by 1 becomes double the value of R2. So this 0 0 1 becomes 1 0. 1 0 means 2. So now we are going to add, still it is not completed. We have to add R1, R2 left shift by 1. Then answer should be stored in the destination R0. So 2 plus 2 is 4. So that 4 is actually updated here. So now original value of R0 is 0. Original value of R0 is 0. Now R0 is actually 4. And source operands, okay, R1 and R2, they will have original value. R1 is 2 only. R2 is also original value. Only destination register value will be updated with sum of those two register. One is taken directly R1, but R2 in the barrel shifter left shift by 1. And in this particular case, actually, it is also add instruction. No, in this add instruction, actually, you can write that it is updated only, but previous instruction, suppose if it is 0, suppose the previous instruction carry is 1. Suppose previous instruction carry is 1. Now actually there is no carry and there is no 0 also resulted. Okay, then we can tell that carry is updated by once again 0. Carry will be cleared and it will be 0 only. But in this, if you assume carry is already 0 and this one, you can write here one sentence. CPSR is going to affect, okay, CPSR current program status is going to get updated if it results 0 or if there is a carry, if there is a overflow. For all arithmetic instructions, CPSR is going to update it. Here it's updated once again with 0 only. Already it is 0. Okay, because why it is written that's not updated means, suppose previously carry flag is 0, that flag is 0. Here it is not resulting 0 answer. So whatever value is there, no same value will be there. That's why we can assuming that, and we can write updated, or better you write here CPSR is going to get update. Okay, once again, and it will be updated and according to the result. But here your answer is not 0. and it is, you can write updated or not updated. Actually, usually for arithmetic instruction, you should update. So let me check in the instructions. If you have any doubt, once again you check it out. Arithmetic instruction, okay. In the arithmetic instruction, once again you check. If it results 0, actually it is going to get affected. Arithmetic instructions, subtraction and subtraction sign values. Okay, these are the add 32 bits RD and RN. Okay. Yeah, here actually S is not there. Actually, S should be there actually. So you can write S means update the flag. I think for addition also S should be there to update, I think. Otherwise, carry will be there. But if you want to save the content, okay, you can check it out. In the textbook also, you can refer whether the carry flag is going to get affected or not. Okay. Pre means before. Okay. So they are not given here any examples on that. But let me take here for subtraction, there is a S. Okay. So S means it's going to update the flag. So here I think you can leave it. CPSR is not updated only. Okay. CPSR is not updated only. If any it results actually in any carry or any 0, it is actually going to set, but it is not going to save. Okay. So you can write not updated only because S is not there. So what is the meaning of this? R0, R1, R2 means R1 and R2 are the source operands. R1 is taken directly. R2 is logically shifted by 1. Logically shift 1 means multiplied by 2. So after multiply by 2, it will be added with R1 and answer will be stored in R0. So next instruction is sub R1, R0, R1, R2. So destination is R0. Okay. Source operand is R1 and R2. So normal subtraction R1 minus R2 will take place. Reverse subtraction means R2 minus R1 will take place. So R1 minus R2 answer will be stored in R0. So let me go to the second slide. This question sub R0, R1, R2. So R0 is equal to, yeah, second problem is here only. Okay, second problem is here only. Sub R0, R1, R2 means destination is R0. It is R1 minus R2. So destination is R0. R1 is how much? R1 is 2. R1 is 2 minus R2 is 1. 2 minus 1 is 1 only. So destination R0 is, this is 1. This is correct. Hexadecimal 1. And R1 and R2 are the actually operands. They are not going to get modified only, and in the ALU subtraction, normal subtraction will takes place and answer will be stored in RD. Okay. And CPSR is again not updated because there is no S here. There is no S here. So actually in the textbook problem, example problem, there is a S here. For any update or save the flag, actually S should be there. So here CPSR is not updated. So third instruction is reverse subtract. Reverse subtract R0, R1 as 0. So destination is R0. Okay, reverse subtract means normal subtraction is R1 minus R2. We did R1 minus R2. Reverse subtraction means we can give any register or we can give some immediate value also. This is some immediate value. So from 0, normal subtraction is R1 minus R0. If I give sub R0, R1, as 0 means from R1 you have to subtract this number. Okay, in the reverse subtract, from this number you have to subtract this. So it is 0 minus R1 and answer is stored in R0. So R0 is equal to 0 minus R1. Okay, 0 minus R1. So this is 0, immediate value 0. Okay, this one, we are doing this one now. 0 minus R1 because it is a reverse subtract. So 0 minus R1 is nothing but minus R1, which is actually 2's complement of R1. Okay, take 1's complement of R1 in the digital. Okay, in the all microcontrollers, microprocessor and all the negative numbers are stored in 2's complement. So you have to write 2's complement of this. So 0 minus R1 is minus R1. So minus R1 means take 1's complement of this R1. R1 is 0, 0, 0, 0, 0. 2 is this. 2 is written in 4 bits form. It is in hexadecimal. This is in binary. Take 1's complement. 1's complement means replace zeros by 1, zeros by 1, zeros by 1. This 0, 0, 1, 0 becomes 1, 1, 0, 1. After that, that is actually 1's complement. 2's complement is 1's complement plus 1. Okay, it is 1's complement plus 1. So add plus 1 to this. Okay, plus 1 to means 1 plus 1 is 0. Carry 1. 0 plus 1 is 1. Okay, this is add 1 now. 1 plus 1 is 0. Carry 1. Okay, 1 plus 0 is 1. Then actually all are zeros, no? So it will be 0. So all 0, 0, 0, 0, 0 plus 1. So 1 plus 1 is 0. Carry 1. 1 plus 0 is 1. This 1 plus 0 is 1. So remaining all are 1. So it is 2's complement of this 2. You are going to get FFFE. So FFFFF is minus 1. FFFE is minus 2. Okay. In 32-bit form, if I take signed number representation, full all 8-bit F is actually minus 1. Then FE is minus 2. FD is minus 3, like that. Okay, because in the signed number, MSB is 1. So answer is, this is FFFFE is minus R0, which is nothing but minus 2. R1 is original 2, R2 is 1. And here also CPSR is not updated because there is no subscript S. Fourth instruction, there is a S, that is update the flag. Sub S R1 comma R1 and immediate value 2. They are not given any R2 register or sub register. They are given the specific value here. So destination is R1 and one of the operand is also R1, and you have to subtract 2 from this R1. So in the normal subtraction, okay, this fourth instruction actually going to do destination is R1. One of the operand is R1. From this R1, you have to subtract 2. So R0 is actually, we have to write updated flag now. So what is the value of R1? Actually, see, R1 is 2. R1 is 2. From 2, we have to subtract 2. R1 is 2. We have to subtract 2. So 0 minus 0 is what? 0. So from 2, if you subtract 2, it becomes 0. Now this 0 is going to store in destination. Destination is what? Destination is again R1 only. So you have to write R1 as 0 now. R0 is actually, we are not using R0, so it will be same as original problem. This is the R1. But R1 now, after subtracting by 2, after subtracting 2, this R1 also becomes 0. Okay. Then R2 will have the same value of 1 only. Here, since S is there, since this S is there, update the flag. Current program status register is updated, and actually the answer is 0. No, after subtraction, 2 minus 2 is 0. 2 minus 2 is 0 means 0 flag is set to 1. Okay, this is second problem. Thank you.